In the game of rock, paper, scissors, plasma cutter wins every time. However, knowing what type of plasma cutter we should get can be really confusing. We keep seeing terms like high frequency, blowback, pilot arc, contact start, high frequency start, and scratch start being thrown around. What do these terms mean, and does it matter? Do I need to get a certain type? What if I'm building a CNC plasma table? Do I need to pay for extra options, or is the cheapest machine out there fine? I'm going to explain the most common technologies available. You may find some exception to my explanation because plasma cutter technology has been developed since it was first invented in 1957. So a lot has been tried over the years. All plasma cutters need a DC power supply to maintain the ionized arc. It needs a torch to direct the plasma stream and an ignition source to start the ionization process. Most of the confusion comes from this ignition process. Inside the cutter, a gas is passed through a narrow nozzle at a high speed. Without the ignition process, we just have several hundred volts of DC power on the end of a torch doing nothing. Think of this like an arc welder that has power but has not contacted the workpiece yet. When we touch the welding rod to the grounded part, it makes an arc and we can get to work. This arc is maintained so long as we keep a correct distance between the welding rod and the part being welded. This is what we need to accomplish with the plasma cutter, but ideally without having to touch the workpiece. To do this, a plasma torch needs a method of heating the gas stream to its ionization temperature. When this occurs, the gas becomes electrically conductive. A spark is used to heat a small amount of gas, which then allows the DC power in the torch to ionize the rest of the gas flowing through the nozzle. Plasma torches have both positive and negative in the torch. What you're doing when you fire the torch is making an arc across the two potentials. When there is a metal workpiece within reach of the torch, the arc latches onto the metal. The reason this happens is that the current through the torch is limited by a resistor, making the metal workpiece a more attractive ground. Originally, this was done with a high-frequency pulse, but more recently, this method has become less popular. You can think of high frequency like the energy used to fire a spark plug used to ionize the pressure gas going through the nozzle. All plasma cutting systems use the high frequency starting until Hypertherm developed the blowback system starting in the late 1980s. Regardless of the process, we need the plasma to transfer to the material being cut. One process you will see is scratch start. This uses a high frequency pulse but without a pilot arc, and we will get more into this later. With these torches, the operator has to move the torch very close to or actually making contact with the material being cut. You can compare this to scratch start TIG welders, which were common on many older machines. In those, you have to scratch the tungsten against the workpiece to start the arc. For anyone who's ever used these TIG systems, you know it takes a lot of extra skill and it eats through consumables. Similarly, scratch start plasma systems have a hard time getting the arc started when the material surface is dirty, rusted, or painted. You can still buy cheap import plasma cutters that use this scratch start technology. There are so many options available that there's really no reason beyond low price to purchase these outdated machine designs. Furthermore, they should not be used on any type of CNC machine, as the high frequency discharge will cause electrical noise interference and possibly damage the computer and electronics. This is similar to how you can get interference through your stereo system from the ignition on older cars. You are just asking for problems trying to use a high frequency plasma cutter on any DIY CNC table. Thermal Dynamics was the first major manufacturer of plasma cutters, and as the technology developed into the late 1960s, pilot arc circuitry was created that allowed a strong pilot arc that would fire the torch without being in close proximity to the plate. This used a high frequency discharge inside the torch to ionize the gas. The addition of the pilot arc would allow the ionized gas to penetrate the material being cut even if there was dirt, rust, or paint on the metal. These systems were widely used for handheld as well as mechanized cutting applications. On CNC machines, there had to be careful grounding as well as electrical isolation to prevent the CNC controller from damage caused by the high frequency and the electrical noise emission. Higher-end industrial plasma units still use high frequency, but these are dedicated systems that are properly shielded and grounded for the application. If you're spending $50,000 on a plasma cutter, you can assume they have the system figured out. As mentioned before, some of the cheap import units use a high frequency start. This is common on the plasma welder combo machines. This allows them to use the high frequency circuit for both the plasma cutter and the TIG welder. This is fine for small jobs, but as I mentioned, I would not try to use one of these machines on a CNC table or around sensitive electronics. This here is a cheap import combo unit that I have. This is a high frequency unit. It has a plasma, stick, and TIG capability. I purchased this because I needed to do some off-grid work and I had to run off a generator. Even with the 10,000 watt generator, I could not even start my large Hypertherm plasma cutter on the lowest setting. However, this small cutter didn't have any issues. I was only cutting 1/4" steel on a loader bucket, so I did not need a lot of power. Please excuse my rough welds, as this was my first time stick welding off a generator and it was not very dialed in. However, I figure it gives it that authentic homesteader look that's so popular right now. My point is that you need to keep in mind your available power and how you're going to use the plasma cutter before you commit to buying something. This unit here is model number CT520DP. This unit is also available as a CT520D. The P stands for pilot arc. You're going to pay about an extra $100 for this. I spent this extra money because I needed this feature to cut through rusty metal. If you don't have the pilot arc, you'll need to grind off any paint or rust or the arc will not start. I would highly recommend spending the extra money to get this feature. It is possible to add a pilot arc to a non-pilot arc machine, but to do this correctly requires adding additional circuitry to disconnect the pilot arc after the main circuits start. Some videos on YouTube show how to create a pilot arc on a non-pilot arc machine by adding another conductor to the torch. However, most of the videos do not add the required relay to turn the pilot arc off after you begin cutting the metal. This wastes power by maintaining the pilot arc back to a ground instead of cutting the metal. This could also damage your machine. If you already have a high frequency machine that needs a pilot arc, this is an option. But if you're buying a new machine, you will spend more money on the proper electronics to make this work than you would spend just trying to purchase this feature already incorporated. As we moved into the early 1990s, Hypertherm incorporated the blowback system to replace high frequency on most of their plasma cutters. They had the first pilot arc plasma torch that could cut through paint and rust that did not use a high frequency discharge to ionize the gas. This technology eliminated a lot of circuitry and propelled Hypertherm to be the largest producer of plasma cutters in the world. The blowback start system uses a spring-loaded electrode that blows back to open a contact at the beginning of each cut cycle using the cutting air pressure to compress a spring that is holding the plunger against the electrode, completing a circuit. The early designs had a spring-loaded plunger built into the torch itself. I have one of these in my shop that I use regularly. This is my 80 amp Power Max 1100. It's a good solid heavy duty unit, but the original torch that came with it was an older technology and it ate through consumables quickly. This torch I have now is a retrofit that uses a newer consumable design. You can see the spring-loaded plunger here. This plunger makes contact with the electrode, and when the gas pressure triggers it, the plunger is pushed back, opening the circuit and making a spark. This spark is created similarly to how disconnecting a battery under a load will make a spark. Here I am disconnecting a car battery under load as an example. In my example, there's a large amount of current flowing through the circuit. In a plasma cutter using blowback, a higher voltage is used to make the spark without the high current. The reason the spark happens is when you disconnect the wire, magnetic field in the circuit collapses. This collapsing magnetic field will produce current. However, since the circuit is open, the moving electrons or the current has nowhere to go. This current accumulates on the open end of the circuit or the electrode. This produces a high voltage potential as electrons build up. This voltage increases until it is high enough to jump the gap, and that makes a spark. By using this spark technology, it allowed for the elimination of the high frequency and the development of new generation of low-cost CNC plasma cutting machines that can use standard computers without the special shielding, grounding, and electronics hardening. As I show here, my CNC table with the blowback ignition does have its own dedicated grounding rod. However, this is pretty minimal compared to what is required for a high frequency unit. The plasma cutter on my CNC table is a Hypertherm Power Max 65. This uses a newer design blowback style electrode. This electrode has a spring-loaded plunger built into the electrode. This makes the plunger a consumable part. This adds a little to the cost of the consumables, but it removes a wear part from the torch to increase the reliability. You can see the spiral that's built into the electrode. This spiral is located in the airstream right after where the spark is created. This spiral provides an increased surface area for the gas to be ionized. Once the gas is ionized, it travels to the tip of the electrode where the high temperature tungsten insert can provide the current needed to cut the metal. All blowback systems have a pilot arc, making them ideal for CNC plasma tables because they do not need to make contact with the part. This is important because the cut has to start above the workpiece. The torch maintains its distance between the workpiece by reading the voltage between the torch and the table. Also, letting the torch drag on the workpiece will create friction, and this will cause a fault state because the machine will think that it's hit an obstacle. Finally, having the torch this close to the work will cause molten metal to blow back and damage the nozzle orifice. This is especially important when cutting thicker plate that'll splatter a lot of metal until the arc penetrates. Years ago, I had an older high-frequency ESAB plasma cutter with a pilot arc. I was going to use this for the CNC table I was building. It was a good machine, but after I did some research, I decided to keep it for manual work and buy a blowback style unit for the project. Also, keep in mind that it can be difficult to have the CNC controller reliably tie into the electronics to trigger the torch on some of these older machines. This could also be an issue on some of the cheaper import units. My Hypertherm PowerMax 65 unit and many others on the market have a built-in connection for tying into a CNC controller. Both the high frequency and the blowback technology will eat through consumables. However, you can improve the performance and the longevity by making sure that the air you use is free of oil, moisture, and dirt. Also make sure that the torch consumables are free of dirt and slag. There are very small holes that direct the air in a plasma cutter. If they get clogged, the cut quality will suffer and the consumables will deteriorate rapidly. I want to elaborate a little more on the pilot arc, as this is critical to plasma cutter performance. To create an arc that does not need to initially touch the workpiece, you first need two things to happen. First, we need to create a very high intensity spark within the torch body, similar to how I demonstrated with the battery or the blowback design, or as how I explained with the spark plug concept for the high frequency design. This creates a small pocket of plasma gas. This is your pilot arc. The pilot arc can complete its circuit within the torch head until it's brought close to the workpiece where it ignites the main plasma cutting arc. This pilot arc is on a timer and will go out if it doesn't complete the circuit on the workpiece. On some machines, the pilot can be set to produce a continuous pilot arc for interrupted cuts, such as when cutting expanded metal. However, this is harder on the consumables. Pilot arcs are confusing because they're separate from the start type. Both high frequency and blowback units can have a pilot arc. However, all blowback units have a pilot arc, while the high frequency units can have a pilot arc or they could be scratch start. To be more confusing, the high frequency can also be called high voltage because the high frequency circuit is typically at about 15,000 volts. The benefits of a high frequency start are that there's no moving parts in the torch and there aren't any misfires. However, for non-pilot arc units, you will need to stay close in contact with the workpiece. The negative of the high frequency is that it interferes with electrical controls, computers, and stepper motors. This is why high frequency CNC tables have to have purpose-built electronics. The benefit of blowback systems is that there isn't any high-frequency interference. This makes them ideal for DIY CNC plasma tables. The negative is that there's more moving parts and more misfires. In my experience, I've been able to eliminate most of the misfires using a water table. The water seems to keep the torch head cleaner. If I run the system dry, misfires become a real problem. For most people, the positives of the blowback system will outweigh the negatives. Remember that either system will go through paint and rust so long as it has a pilot arc. Regardless of the system you have, the ground clamp will need to be attached to bare metal of the part being cut. In summary, blowback, or contact as it's sometimes called, starts with a pilot arc and is the latest technology in air plasma torches used for handheld cutting as well as entry-level and light industrial CNC cutting machines. High frequency starts with a pilot arc is still used in liquid-cooled 100% duty cycle industrial plasma cutters. High frequency is also still used on some cheap units which may or may not have a pilot arc and are not appropriate to use around sensitive electronics like office PCs that are used to control most inexpensive and DIY plasma tables. When it comes to which machine you should purchase, that's an individual decision based on how much you plan to use it and what your budget is. Hopefully you are now armed with enough information to make an informed decision. We will look more into the machine specifics in future videos, but this is long enough already. I'm working on many additional videos that'll cover plasma cutting, fabrication, and engineering. If you would like to follow along, consider liking and subscribing to stay up to date with my future releases.